So this is the flow work and the energy of a flowing fluid. So flow work or flow energy, okay, what does it mean? The work or energy required to push the mass into or out of the control volume. So this work is necessarily for maintaining a continuous flow through a control volume. So we know that force equals to pressure multiplied with cross-section area, okay. Therefore, workflow equals to FL, okay. Workflow equals to FL. The force and the distance equals to PAL. Okay, L is the length or the distance. Okay, AL is equals to PV. Okay, so workflow equals to PV. So this one is actually similar with previous work of boundary that we have applied before. Work boundary equals to PDV, right? Okay, this time is workflow equals to PV. Okay, so this is an imaginary piston. Okay, so we push the piston. Schematic for flow work. Okay, so imaginary. So it just we assume that we have a piston here just to push the inlet stream, inlet flow. Inlet flow. Okay, into the open system or control volume system here. Okay, so workflow and before entering, this is workflow after entering the system. Okay, so in the absence of acceleration, the force applied on the fluid by a piston is equal to the force applied on the piston by the fluid. Okay, so for open system overall, this is the equation that we're going to apply. Okay, so the energy content of a control volume can be changed by mass flow as well as heat and work interactions. So we have mass in, mass out, we have work in, work out, we have Q in, Q out. So there are three things need to be considered, okay, for open system. Okay, total energy of a flowing fluid. So we have specific energy equals to specific internal energy and kinetic energy plus potential energy. Everything's over the mass, okay, remember. Therefore, it is also equals to specific internal energy plus V square over 2. And this one is already over the mass. Therefore, the mass is has been eliminated, and we have mgz or mgh. So mass is everything's over the mass, so we don't have mass at here. So this is the equation, okay, that we can try to apply. We have another new thing at here. So what is this? Okay, what is this? This is the equation. This is for the equation for flowing fluid. Okay, we have data here equals to PV plus E. Equals to PV plus E. We know that E is equal to this. Okay, so therefore theta here is when PV equals to plus E. PV plus E, PV plus all the things here, okay, all the things here, and we know that H equals to U plus PV. Okay, so when U plus PV, then you have this equation. Okay, theta equals to H plus V square over 2 plus GZ. Okay, so these are both these are the equations that you can use for non-flowing fluid and flowing fluid. For non-flowing fluid, you have these equations, okay, which U is internal energy, this is kinetic energy, this is potential energy, but this time you have flow energy. Okay, work equals to PV, remember. Okay, flow energy equal plus the non-flowing fluid equation just now. Okay, so the total energy consists of 3 parts for three parts for a non-flowing fluid, okay, and 4 parts for a flowing fluid. Okay, you have to solve each of it. Okay, so this is non-flowing fluid equation, this is flowing fluid equation. Okay, so the flow energy is automatically taken care of by enthalpy. So in fact, this is the main reason for defining the property of enthalpy. Okay, so we have flowing fluid. This is also theta equals to H plus V square over 2 plus GZ. Okay, we have enthalpy for flowing fluid as well.